Hey y'all. So today's lesson is volume of a triangular prism. We've gone over surface area of triangular prisms and we've gone over surface area and volume of rectangular prisms. So just a reminder, volume is the space inside a 3D figure. And for a triangular prism, we start off volume with the formula, capital BH. Capital B stands for the base area. So for a triangular prism, the base area is a triangle. It's a triangle. So we are going to use 1/2 BH. You saw that before when you did surface area. And then the height just comes down as the height of the prism, the height of the rectangle. So if you were to take this prism and you were to put it on its base, on the triangle, so you were to stand it up, how tall would it be? It would be the height. So that's this height right here, the height of the rectangle. This first is the height of the triangle because it's the base area. And then don't forget that it's units cubed. So let's do some examples together. So example 1, find the volume, and these are all 3D. So if you have your calculator, pull your calculator up on your computer or your cell phone. And here we go. We have a triangular prism, and I've already shown you the volume, capital BH. And then you break it down to 1/2 BHH. The first BH comes from the triangle. So this comes from the triangle. The base of the triangle is 4. The height of the triangle is 3. So you notice I already have...
Miss Pam Grant, please call extension
Sorry.
100, Miss Pam Grant.
I already have 4 and 3 in my formula. The second H is the height of the rectangle, and 8 is on the rectangle, so that's where the 8 comes from. I don't use the 5. I put it in the problem, but you end up not using the 5 at all. You use it for surface area, but you do not use that extra side for volume. And then you can type that in your calculator. 1/2 times 4 times 3 times 8. So let's see, 1/2 of 4 is 2, 2 times 3 is 6. So this should be 48 centimeters cubed. And that is the volume of this triangular prism. That's how much space can fit inside. That's how many centimeter cubes. If we have tiny little centimeter cubes and we could put them inside, we could fit 48 centimeter cubes into this triangular prism. Let's do another one, example B. So we start with our capital BH, 1/2 BH times H. And again, the first BH has to come from the triangle. The base of the triangle is 5. And the height of the triangle is 4. So I put in 5 and 4. The second H is the height of the rectangular, the prism. So if I were to take this triangular prism and stand it up on the triangle, it would be 10 inches tall. So that's the 10. I did not give you the sides of the triangle, but if I had given you these sides, you would not have needed them because you don't use all the sides. You only use the base and height. And when we find this, the volume is equal to, let's see, 100 inches cubed. 100 inches cubed. I hope I did that right. Let's see, 1/2 of 10 is 5, 5 times 5 is 25, 25 times 5, yep, 100 inches cubed. Alright, so now let's find volume using the nets of triangular prisms. You have to know how to use the net of a triangular prism, and we do the same thing. You notice over here I have my formula, capital BH, and then 1/2 BH times H. So the first BH comes from the triangle. What is the base and height of the triangle? So I have 6, 3, and 4. And hopefully you remember that the base and height are going to be the ones that form the right angle. They're perpendicular, the base and height. So I'm going to use 1/2 times 6 times 3. I do not use 4. I do not need the extra sides of the triangle. I'm using the base and the height of the triangle. The second H comes from the height of the prism, the rectangle. So how long are the rectangles? And they are 11. And then my volume is going to be 1/2 of 6 is 2, 2 times 3 is 6, so 66 meters cubed. And that is volume of a triangular prism. Let's do another net. I have my formula, and then I have 1/2 BH times H. The first BH comes from the triangle. So the base of the triangle, I've got 4, 5, and 6. And hopefully you remember that the base and height form the right angle. So right here, the right angle, 4 and 5. And then the height of the rectangle, we don't use 6. We don't need 6. We use the rectangle, and that's 15. So our volume is 5 times 4 is 20, so half of 20 is 10. So 150 feet cubed. All right? And those are 2 net examples. Examples from
Good
nets.
afternoon, staff. This is last call for today's received money. Last call for today's money.
All right, so E is a U try. I want you to try this one. Find the volume of this triangular prism that I drew out for you in 3-dimensional. Pause the video and then press play when you're ready to see the answer. So I have my formula, capital BH, and I'm going to do 1/2 BH times H. This comes from the triangle. So the base of the triangle is 8. The height of the triangle is 6. And then I have to use the rectangle. And this one I'm going to have to use a calculator. Half of 8 is 4. 4 times 6 is 24 times 18. And I got 432 inches cubed. Let me make sure. 8, 6, 18, 432. All right, so I hope you got that right. 432 inches cubed. And now let's do 2 real-world problems. 2 real-world problems. Oops, smudged it. Real-world number 1, how much space is inside the tent? So whenever you're looking at words like space and inside, you know that it's going to be a volume question. We have over here a tent for you campers out there. If you like to go camping and you set up a tent, how much space can you fit inside? And that would be volume. So we start with capital BH, and then we bring down 1/2 BH times H. The base of the triangle is 8. The height of the triangle, so you have to decide, are we going to use 7 or are we going to use 6? Hopefully you know that you're going to use 6 because that makes the right angle. And then the height of the prism would be 12. And the volume of this would be, I don't know, let's type it in. 1/2 or 0.5 times 8 times 6 times 12, and the volume would be 288 feet cubed, or cubic feet, and that means you could fit 288 feet cubed, or cubic feet of space inside that tent. It'd be really, really crowded if you tried to squeeze that much, because then you fill it to the max, but that's how much space can fit inside that tent. All right, so real world number 2. How much candy can fit in a Toblerone box? So let me bring back my friend, the Toblerone box, the candy. Oops, that's upside down. And how much space can fit inside? If we really wanted to put candy inside of it, how much space could fit inside the Toblerone? And here is a Toblerone box, chocolate, and we are going to find the volume. 1/2 BH times H. You should have that formula memorized by tomorrow. You should be able to quote that back to me. Then I am going to, the base of the triangle is 1.5. The height of the triangle is 1. And the height of the box is 8 inches. So you are going to type that in to your calculator. And 1/2 times 1.5 times 1 times 8. And it looks like the volume is 6 cubic inches or 6 inches cubed. And that is how much space can fit into or that's how much chocolate can fit into our Toblerone candy. All right. Oh, that's it. I thought there was one more. I was going to do another one. So we are going to practice volume tomorrow. So I hope you understood it. Write down your questions, and I'll see you tomorrow.